Welcome to Kenton Teaches. Enjoy the video.
You start by matching required frequency. Wave or sub-6 GHz dictate dimensions and materials. Choose substrate dielectric constant and thickness for resonance. Once done, select patch geometry and feed type. That determines impedance and bandwidth. Prepare a PCB layout and run an EM simulation to validate S11 and radiation pattern. Make sure to gather SMA or precision RF connectors, adhesives, and ESD-safe tools. Begin with a printed prototype sheet and cutouts so you can iterate rapidly when tuning is needed. You now fabricate the PCB pattern using milling or chemical etch. Tight tolerances influence resonant frequency, so aim for 0.1 mm accuracy. Solder the feed network carefully. Microstrip lines require controlled impedance, while coax probes need precise insertion depth. Once the radiator is mounted, install the matching network, stubs, vias, or discrete shunt components to achieve 50 ohm. After assembly, perform a bench VNA sweep to check return loss, and adjust trimming tabs or capacitor values until the resonant peak lands at the target frequency. You finish by measuring S11, axial ratio, and gain. Use an anechoic chamber or open-range setup to capture the radiation pattern. If the antenna is off frequency, trim radiating edges, change feed length, or replace matching components to shift resonance. Once tuned, encapsulate with a radome or waterproof enclosure and revalidate performance. If problems persist, check connector continuity, solder joints, and ground plane integrity, common failure points, and retest after each correction to confirm the antenna meets 5G performance expectations.
Thanks for watching. Please subscribe if this video was helpful.